Hi, I'm Jordan.
And I'm Kit.
Welcome to Starry Time, where stars plus lines.
Equal stories.
For this month, we'll be exploring the constellation Perseus. You know, the ancient Greek quote, hero?
Yes, just Perseus, another one like Hercules.
hmm
So, in this episode, we're going to talk about the astronomy and other cosmic background of this constellation. If you listened to our episodes on Cassiopeia, Cepheus, and or Andromeda earlier this season, it should come as no surprise to you that Perseus is another of the 48 great.
Great.
Constellations identified by Ptolemy in his 2nd century Almagest. And this should be no surprise because Perseus is also part of that entire saga.
And it is quite a saga indeed. We needed several months away from that myth verse, to
Uh-huh.
be honest, before we could really return to talk about Perseus. But we'll save those thoughts for next week's Myths and Retcons episode.
Yeah, and Perseus also has some other notable myths that we will roll into that episode next week.
Lot going on with our
hmm
guy Perseus. Speaking of, the constellation we call Perseus was sometimes called Perseus and the head of Medusa, and the constellation was illustrated with Perseus holding the Gorgon's head. But the IAU doesn't use this name, does not allow Perseus to accessorize with the dead skull of his victim,
Mm.
and it didn't really catch on. So we will just refer to it as Perseus for this month.
Yeah, it's probably for the best. And, I sort of wish that Perseus didn't catch on, but,
Mm.
I think this should just be a main ad constellation.
I mean, in my reconciliation, it might be Medusa holding up the head of Perseus, but when we take over that IAU, I'm sure we'll, make sure a lot of changes that we see fit are finally made.
All right, I will hold off on my Perseus character gripes,
hmm
much like I did when we got to the Orion myth gripes.
hmm
Yeah, it's not I think the problem is like I'm not as attached to this constellation as I am attached to the constellation Orion. And so all I can think about is Perseus the quote unquote hero. And I need to let that go so we can really get into the astronomy of this constellation.
Kit, to be fair, we all do have our biases. However, this constellation is actually larger than Orion. It is the 24th of the IAU recognized constellations compared with Orion's 26th ranking.
So perhaps the difference isn't in the size so much as the findability in the night sky. So before we get technical about it, what does this constellation look like to you, Jordan?
Based on the pictures I saw, this one was pretty representational. It actually looked vaguely like a stick
hmm
figure, or vaguely like half of a stick figure at least. It also reminded me of the ancient Greek letter lambda. But yeah, this one I wouldn't say was super complex, but I could see how it could become a person. How about you? What do you see here, Kit?
Yeah, same. So I kind of see like this one leg figure with a tiny little hat and flailing arms. So yeah, something definitely human like here. Yeah, I begrudgingly will admit that there's something human like, but it's not as tidy and
Hmm.
clear as the 3 stars of Orion's belt and the head and the 2 feet and the arms, but.
I'm glad that you also saw or imagined the flailing arms.
Yeah.
That definitely stuck out to me. Maybe that's just the Perseus we want to see, just arms flailing, toppling over down the stairs. But yes, as we mentioned earlier, Orion is a lot to live up to. And you're right, Perseus doesn't have a lot of super bright stars to find. Perhaps the easiest way is to go first to his mother in law, Cassiopeia.
Right. The constellation Cassiopeia is a vaguely W or M shape in the night sky, very, I think, noticeable. If Cassiopeia is up there looking like a W, then you'll find Perseus below and to the left. If she's looking like an M, then Perseus will be to the lower right if you follow one of the center stars of Cassiopeia.
and its other neighboring constellations we've discussed on the pod before, including Aries and Taurus to the south, and
Auriga.
Auriga to the east, and Andromeda to the west.
And if all of that doesn't help, it has a right ascension of about 4 hours and a declination of 40 degrees north.
If you live above positive 40 degrees latitude, this constellation never sets below the horizon. But otherwise, you can see it high in the night sky in the rest of the northern hemisphere and in parts of the southern hemisphere in November.
So now that we know what it looks like and where to find it, let's talk about the brightest star in the constellation.
Kit, I have excellent news.
Okay.
Our favorite late 16th century astronomer slash lawyer, Johann Bayer, absolutely crushed this assignment. Knocked it out of the park, designating the brightest star in this constellation as Alpha Persei, which is better known by its formal name of Mirfak.
Oh, I'm so proud of our guy. I mean, really, it's so hard to be a late 16th century astronomer slash lawyer. You had to have so many jobs. I mean, wow.
Bayer, we never doubted you. So the formal name Mirfak comes from an Arabic phrase meaning elbow. It is a yellow-white supergiant star with an apparent magnitude of positive 1.81, and it's located about 510 light years from Earth. It is more massive, larger, and more luminous than our sun by like a lot. Like a lot. For example, it has 68 times the radius of our sun, and it is 8.5 times the mass of our sun.
Yeah, that's big. So remember that the radius of our sun is about 432,000 miles, which is 109 times the radius of the Earth. So this is a big star. It's likely evolved, right, on that main sequence, and it's probably going to be ready for a collapse sometime soon.
Back in 2010, astronomers published a paper suggesting the star might have a gas giant about 6 times the mass of Jupiter orbiting this star, but this hasn't yet been confirmed. And there is some evidence to suggest the initial findings might have been incorrect, or a star spot, or another artifact in the data.
Yeah, I guess we're going to need some more research on this star to learn more.
Perhaps it's there, perhaps it's not. One other interesting thing I've learned about this star is that it is the only star in Perseus that is considered a navigational star.
Ooh, yeah. I don't think we've talked about navigational stars on the pod before. Maybe we want to do a quick snapshot on them and loop back on it some other time, but just maybe a short picture of what a navigational star is.
Kit, of course. And there are 58 special celestial navigation stars in the night sky. Well, technically, there's 57 and Polaris. But these stars are used to navigate by seafarers, especially since on the sea, all you got is ocean. Ocean. And if
Hmm.
you look around, Kit, you wouldn't believe me, but more ocean. So if your satellites go down, or perhaps you're trying to navigate by sea before we even had satellites,
Mm-hmm.
perish the thought, and you want to ensure you're going the right way, you could use these very special stars to help guide your ship.
Yeah, very cool. And there is celestial navigation when you are, wandering around in other places, but it's pretty clear why you might need stars since there's no landscape to look at when you're on the ocean.
Let's move into our next segment, which is Bayer's variable star. Here we follow the Greek alphabet to learn more about the Bayer designated stars in the night sky. Last month, I swerved a little bit and tried to find something a little bit more interesting. No respect to New Lyrae, but where did you go with this one, Kit? Did you follow the alphabet and the assignment? Or were you swept away by some other star of interest?
Well, I'm famously only a rule bender, not a rule breaker. So I'm going to do a little like yes and here.
Kit, you're
Mhm.
almost the avatar of rule bending.
Thank you. Okay, so first things first, let's talk about Kasai Persei, which is it's spelled sort of like, or it's transliterated as XI, but it's pronounced, I think, Kasi or Kasai, something like this. It's Greek, so I don't know. It's a Greek letter. This would come after Nu in the Greek alphabet. And this star also has the name Menkib, which is derived from an Arabic word meaning shoulder. It has an apparent magnitude of positive 4.06, and it is an O-type blue giant star.
Since it is a blue giant, it's got to be pretty bright, right? So it's got to be far away if the apparent magnitude is so high.
Absolutely. So its absolute luminosity is way, 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 way brighter than our sun. And the star itself is 30 solar masses. So it's huge and it's very bright and luminous, but it's 1,200 light years away. So it's
Wow.
quite far away,
Yeah.
exactly. Um, this star is also a suspected runaway star, and its radiation is part of the reason why the California Nebula, which is located in Perseus, seems to be glowing, if you've ever seen a picture of that nebula.
All right. XI, Persei. I don't know how to say you either,
I
but
know.
pretty cool.
Yeah, so there was actually something kind of interesting about it. So I wanted to make sure we got back on track, but I also really feel it's necessary that we do a quick shout out to Beta Persei.
Kit, that is why you are Avatar, the last rule bender.
Well, I have to because Beta Persei is probably the most famous star in this constellation. It's also called Algol, which is derived again from an Arabic phrase meaning the head of the ghoul or the head of the ogre. And this star is considered unlucky. It's known as the demon star. It's known as Satan's head. So, yeah.
Wow, that's quite an escalation. We started from elbows and shoulders, but you keep making your way up to the head, and stuff starts getting really real here.
Yeah, so in the ancient Greek mythos, this star is symbolizing that head of Medusa that we mentioned earlier. And it in reality is actually 3-star systems. So it's been confirmed to have 3 stars. There might be some additional companions, maybe even a 5-star system, or there might be some, optical binaries. And the main star is, in fact, an actual variable star.
Which means its brightness as perceived from Earth, aka its apparent magnitude, changes over time, usually in a set interval or within a relatively short period of time.
Mhm.
So this isn't something like a supernova or a nova where it brightens temporarily and then fades.
Exactly. So it sort of has this brightening and dimming effect that happens over time. And this variable brightness in Beta Persei is caused by the orbits of the stars, which cause them to eclipse one another at these regular intervals. So every 3 days or so, one of the pairs, which is an eclipsing binary pair, orbits each other, they eclipse each other, and this pair is 0.062 AU from each other.
Kit, that is very, very close.
Uh-huh.
Let's remember that 1 AU is about the distance from the Earth to the Sun. Though in 2012, the IAU made a more specific redefinition.
Yep, absolutely. So there's a slightly more technical definition, but in general, we're talking about, much, 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 much smaller, these stars, right? Orbiting one another very closely. And there are some really cool visualizations of this system. So I will be sure to post those over on our socials at Storytime Pod on the Universidon Mastodon server and, of course, over on Twitter.
Kit, I can't thank you enough for getting Bayer's variable star back on track. Let's take a quick break, and then we'll come back to find out about my pick for Gold Star of the Month.
Welcome back. This segment is called Gold Star. In this segment, we alternate picking the star or space object in our constellation of the month that captures our minds, our hearts, and our very souls. So, Jordan, what was your pick this month for Gold Star?
Well, Kit, there was a fair amount to choose from this month in
Hmm.
Perseus. But as soon as I read about this one particular deep sky object, my decision was made for me.
Yeah, this part of the night sky is really interesting because it does align with the galactic plane of the Milky Way. But there's a lots of sort of molecular clouds that are hiding and obscuring the usual stuff that we see in this part of the night sky and that we can sort of see on the galactic plane.
Yes, Kit, exactly. And one of the major things in this constellation is the Perseus cluster, which is also known as Abel or Abel 426, and it's one of the closest galaxy clusters to Earth at about 76.6 million light years away.
Just a veritable hop and a skip away.
It's all relative. It is one of the closest.
Hmm. Mhm.
But what really captivated my heart was the giant elliptical galaxy at the center of this cluster called NGC 1275, also known as Perseus A or Caldwell 24.
And these names are all so exciting and so captivating.
Yeah, you instantly remember them. NGC, what was the number again? NGC 1275
Mhm.
and Cornwell? No, Caldwell 24. This galaxy is a Seyfert galaxy, which at visible spectrum look like regular old galaxies, but they have extremely bright active nuclei. And such active galaxies, as they are called, are designed as active galactic nucleuses, or AGNs.
And you're right. So we can see these AGNs, these really active bright nuclei outside of the visible spectrum. So things like radio and X ray. And this is important. The Milky Way, our home galaxy, is not an AGN.
Kit, unfortunately, you are correct. Our Milky Way, whatever it has going for it,
Mm,
does not have active galactic nucleus status
mhm.
because these AGN galaxies have supermassive black holes that are actively accreting matter. NGC 1275, as a Seyfert galaxy, has a quasar like center. NGC 1275 is special since these Seyfert galaxies only account for about 10% of all the galaxies that we've found.
So rare and very active, right? And this idea that, we in the Milky Way, we do have a supermassive black hole at its center, but it's not
Mm.
accreting matter. So, okay, I'm still with you.
Kit, yes, this is a rare and active galaxy. So, pretty special to me.
Hmm.
And what stood out to me about it, in addition to that, is that there's these super elaborate filaments that surround the galaxy.
Mm.
And these filaments, well, essentially, they're cool gas that's been surrounded by super very hot interstellar gas. And now here's where things get even more interesting. This cooler gas is basically deposited from the center of the galaxy by radio bubbles.
A radio bubble.
Radio bubbles.
What?
Yes, it's so good. Basically, bubbles of relativistic plasma rise out of that active nucleus and into the surrounding hot gas, and somehow have remained in place instead of, warming up or collapsing into stars. Because of this, some astronomers have hypothesized that the magnetic field around these filaments is keeping them intact.
Oh, that is so interesting, right? We have this like really weird dynamic around it where it's like, yeah, how are these cool parts of gas? Like, how is this gas like this? Like, how is it here? That's cool.
Two more things here, Kit. First, these bubbles create sound waves,
Mm.
which apparently sound like a B flat, approximately 57 or so octaves below middle C.
Oh my god. First of all, that is so low and also so specific, right?
Yeah.
Like some astronomer was able to figure this out. That's amazing. You can like hear radio bubbles. That's like yeah, it's a little bit mind-boggling.
Okay. Let me send you the link to put on our socials for sure. There's an excellent New York Times article. Add it to your mixtape. And finally, we've also observed two supernovae in NGC 1275, as if we needed any other reason to give this extremely cool space object the Gold Star of the Month award.
What a great choice. This is a new galaxy type for the pod, complete with a
Mhm.
supermassive black hole, my first love, mysterious and beautiful filaments, a music of its own, and supernovae. Welcome to the Gold Star Club, NGC 1275.
That brings us to the end of our exploration of the cosmic background of our constellation, Perseus. Next week, we will be retelling and reconstellationing the myths of this constellation.
This has been Kit,
And Jordan.
sisters, lovers of stars and stories,
And we'll see you next time.
on Starry Time.